The petrochemical sector is accountable for a third of industrial energy use and for almost a fifth of global industrial CO2 emissions. C-THRU is a 3-year transnational multidisciplinary research project aiming to understand the current and future emissions from the petrochemical sector and explore how interventions and innovations could minimise them.
This important work is being led by researchers at the University of Cambridge and supported by Hancock Hamlin and other partners. Hancock Hamlin is a freelance research facilitating company that educates and coaches engineers to operate efficiently in complex and emergent environments such as petrochemicals.
Well, the project has been structured to take a holistic approach. It's a very sort of complex area, and that means rather than looking at individual subsets of activity, you need to look at the behaviours and the combinations and the interdependencies between different interactions rather than just one specific intervention. With that in mind, with the C-THRU project, we've brought together an exceptional group of people who cover a really broad mix of topics and expertise.
The team brought expertise ranging from macroeconomics and industrial ecology to process technology and economic systems modelling. Together, they were able to understand the interactions across the chemical system.
You can't look at it in isolation because the processes will affect other processes further down the line, which actually could end up exacerbating the problem you're trying to resolve. So you might solve emissions upstream, but the processes that you've put in place actually mean you're making it far worse downstream. So unless you take that holistic approach, you could end up being in a worse situation than you want to, which is why petrochemicals is a complex area to look at.
The focus is on minimising the release of carbon emissions into the environment from the production, use and disposal of the most commonly used petrochemicals, such as fertilisers and plastics.
The industry currently is built around taking carbon out of the ground, mainly fossil fuels, and either burning those or creating them into products that might be burnt in an incinerator. And that carbon, a lot of that carbon is ending up in the atmosphere, and that causes climate change. So we think the industry has an exciting opportunity, and that's to invert this carbon vector. So rather than taking carbon from the ground and putting it into the air, there's the possibility of taking carbon from the air and putting it back into the ground. And this creates what we would call negative emissions, emissions that can help offset perhaps other sectors that are difficult to decarbonise.
This, together with the project's other findings, has highlighted the need to train engineers in new ways.
What we teach engineers to do typically is to identify a challenge, break it down into particular problems, and then analyse those problems, understand the detail, and then work out solutions and build out an answer that addresses the challenge. But I think C-THRU actually really exemplifies the way that actually there are other types of problems that don't lend themselves to that sort of challenge. It's just too big. It's too big and it's too complicated to be able to break it down. We have to actually find a different way of educating our engineers. Not different, a complementary way of educating our engineers. And I think that's what C-THRU has been a great example of. It's been a great example of approaching a apparently technical problem in a different way, generating a different type of output that is much more useful. So you've heard about carbon vectors and reversing the carbon vector. It's a really simple idea, but it's a simple idea that gives direction to almost anybody that's interested and enables them to work out their contribution and know with confidence that that contribution is effective. So we've committed our future to creating a movement and creating the ability for engineers and the people that need to work with engineers to work in this different way and hopefully have a much more significant impact on society and the world at large.